Hi, today we are going to be covering 6.3 Day 2. Proving triangles are congruent using what's called SSS and HL. So what we've talked about a while ago, this is way back in Unit 2, we discussed what makes two shapes congruent. For two things to be congruent, every single side and every single angle has to match up to between both shapes. Today, our focus is going to be looking for shortcuts when it comes to proving triangles are congruent. We do not have to show every single angle matches up and every single side matches up. Instead, we're going to find some shortcuts. The first shortcut is what's called the side-side-side congruence. That's what we abbreviate with SSS. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So when I look at these two triangles, I have a single tick mark and a single tick mark, double tick mark to double tick mark, and a triple tick mark to a triple tick mark. These are three pairs of sides. That's, remember what we're saying here. To be side, 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 it has to be three pairs of congruent sides. So since I have that, this is enough to say the two triangles are congruent. I don't need to know anything about their angles. Three pairs of sides match up, the two triangles are congruent. So another recap of back from Unit 2, when I look at these, I can write them as a statement now. If I say triangle ABC, so if you notice that goes from tick marks, it goes 1, 2, 3. That is congruent to triangle RST. Whoops. Nope, sorry. Yeah, RST. That goes the same exact order. It goes 1 tick mark, 2 tick marks, and 3 tick marks. Okay? When writing these congruent statements, they have to be in the same order, or they have to be in consistent order. So for example, if I did triangle BCA, when I look at my two triangles, that order is going to go for the other triangle, STR. So side, side, side is a way to prove triangles are congruent. This is going to lead us to our geometry proofs. Before you talked about algebra proofs. This is an extension off that basically follows the same idea. We need to make sure that every statement we can make has to have a reason to back it up. All proofs, no matter what, start with the given. So in this proof right here, we say that FJ is congruent to HJ, and G is a midpoint of FH. Okay? I am totally fine if you have the same reason for more than one statement. Go ahead and put those two statements in the same box. Okay? That will help save a little bit of your writing, save some space. You do not need to fill in every box on a proof. It's just a matter of what makes more sense to you. So we want to prove that the two triangles are congruent. One nice thing about proofs is we know where it starts with a given, and we know where it has to end. It needs to end with this statement that the two triangles are congruent. My suggestion is let's go look at the diagram. Let's mark it up with things that we know that are true. So it was already given that FJ and HJ are congruent. So that's given to us. G is a midpoint of FH. When I look at that statement, here's one thing I know about that. If G is the midpoint, these two pieces have to be congruent as well. Now, based on our congruence theorem, side, 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 I need a third pair of sides to find this. So when I look at this, you notice that JG is being shared between the two triangles, FGJ and HGJ. If you recall, that's what's called reflexive. So what we're going to do is we just need to make this into our proof now. So again, one thing that, sorry, I just realized that there's another good strategy with this. If my goal, if I can find side, 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 I'm going to try to label all of those three pairs of sides in my proof. One of them's given. The next one was FG is congruent to GH. Okay, there's a second pair of sides. And the reason for that is the definition of a midpoint. So now I have two pairs of sides. I need one more pair of sides, and that was JG. Between the two triangles, JG is congruent to JG. And that's reflexive. Reflexive is whenever something is shared between the two triangles. So in this case, the side JG is shared between two triangles. That's a reflexive side. Well, now I have three pairs of sides that are congruent. That is enough to say that the two triangles are congruent. I have enough to state my final proof statement. Triangle FGJ is congruent to triangle HGJ. And my reason? Side, side, side. Eventually, we're going to have 5 total reasons for triangle congruency. So those are always going to go into the proof of why two triangles are congruent. So we have side, side, side in this case. The next one we're going to cover is called hypotenuse-leg. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So in this scenario, the key thing is it has to be a right triangle that you're comparing. I have two right triangles. I know that because of these two symbols. All I need to prove, if I know I have right triangles, the first thing I want to check is, do I have right triangles? Then all I have to show is a pair of hypotenuse or hypoteni match up and a pair of legs match up. As long as I have that, I can state the two triangles are congruent. We abbreviate that with HL. So in this case, triangle ABC is congruent to triangle DEF. So let's try this in a proof now. So use the hypotenuse-leg theorem in this case. My ultimate goal is to use hypotenuse-leg. So first thing I need to do is I need to make sure I have right triangles. So let's fill out our givens. I got a lot of givens going on, so I'm just going to go ahead and probably use 2 boxes here. So AC is congruent to EC. AB is perpendicular to BD. Okay, ED is perpendicular to BD. And AC is a bisector of BD. Okay, these are all givens. So that's my first step. Let's fill in the givens. My second step, let's go back and mark up the diagram with anything that I can on there. So AC is congruent to EC, that's already been marked up. AB is perpendicular to BD, that gets a right angle. ED is perpendicular to BD as well, also a right angle. AC is a bisector of BD. So what I know about that is when I look at my diagram, this is being bisected at that point. So this is what I know from that. So since AC is a bisector, BD gets split up into 2 equal pieces. So before I go any further, I'm going to go ahead and start filling out what I know. So before I can use hypotenuse-leg, I really should state that I have right triangles. And I could do that in multiple steps, but here's the bare minimum at the very least. Because I have perpendicular lines, I know I have right angles, which creates right triangles. So I'm just going to make a statement that triangle ABC and triangle EDC are right triangles. My reason for that is I'm just going to shortcut that as definition of perpendicular lines. Since we have perpendicular lines, we have right triangles. So that's how I'm going to shortcut that. If I'm going to use hypotenuse-leg as my reason, I should state that the two triangles are right triangles. Now, to get hypotenuse-leg, now that I've stated that they're right triangles, I'm going to go back and I'm going to find, do I have those listed already? Well, AC and EC, that's my hypotenuse part. Because of the bisector, so I could state that BC is congruent to CD, and that is the definition of a bisector. Well, that just gave me my leg. I now have enough information. Since I have the hypotenuse and a leg match up in 2 triangles, I can now state that triangle ABC is congruent to triangle EDC. And my reason is hypotenuse-leg. Those are our 2 triangle congruences for today. Tomorrow we will be looking at 3 more, but for right now, for our practice, we're gonna go focus on one of those 2. So let's try some of these you try nows real quickly. So write a proof for this. So again, I'm gonna start off with my givens. So I have AB is congruent to CD, and BC is congruent to AD. And the reason is because it's given. I look at my diagram, those are already marked up. Now, if I'm thinking about hypotenuse-leg, I need to know for certain that I'm dealing with right triangles. When I look at the given information in the diagram, nothing there tells me I'm dealing with right triangles. So therefore, my next guess is to look for side, side, side. So what I have is 1 pair of sides and a 2nd pair of sides. I need the 3rd pair of sides between the 2 triangles, which is AC. Since AC is congruent to AC, that's called reflexive. And there's my 3rd pair of sides. Therefore, I can now make my proof statement. Triangle ABC is congruent to triangle CDA. And my reason is side, side, side. Whoops, too far. Just let you see that real quick. And again, I don't care if you fill in all the boxes. All that matters is you have enough information written down. Number 2, let's decide whether the triangle congruent statement is true. Are the 2 triangles congruent? Let you think about that for a second. And I would say yes. The reason is because of side, side, side. And again, it's not because I didn't state it, but these 2 sides are congruent. These 2 sides are congruent. And then because of the reflexive property, LK is congruent to LK. Step 3, or you try now 3. Show that you cannot prove the 2 triangles are congruent based on the information in the diagram. When I look at the diagram, I see right triangles. So maybe I could do hypotenuse-leg. But when I look at this, and I do this right here, for the triangle ARM, I could do Pythagorean theorem. If I have 3 and 4 and I want to know this part right here, I could do 3 squared plus 4 squared equals c squared. So I've got 9 plus 16 equals c squared, 25 equals c squared, 5 equals c. Well, that does help in a way, because if c equals 5, I now have the hypotenuse match up. The problem is I don't know KR or RJ. So I cannot prove this because I can match the hypotenuse of the 2 triangles. I can match the 2 hypotenuses, the hypotenuses, but cannot find matching legs. That concludes our 6.3 day 2. So when looking at these proofs in your practice, make sure you have to go off the given information or any information that's given in the diagram. Do not make unnecessary assumptions. That's the toughest thing about proofs. Okay? So you're looking, as of for tonight, you're looking for side, 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 do 3 pairs of sides match up, or you're looking for hypotenuse-leg if you have 2 right triangles. So 2 hypotenuses line up, or 2 hypotenuses are congruent, and 2 legs are congruent.